we're going to get started. So you should be in this room if you're here for the Phaser.js tutorial, so JavaScript, HTML5. This is just our title slide. So this is just the meeting schedule for the rest of the semester. I know we showed it at the last meeting, but we're going to keep showing it as we move down. Today, you're here for the HTML game. In 2 weeks, so after spring break, we're going to do a socket.io tutorial. We're going to build a chat system. So using JavaScript, so the stuff that we're using tonight, we're going to use another JavaScript library called socket.io and build a really cool chat system. That's a little bit more involved. You have a server and the front end and all that kind of stuff. So all of that stuff we'll go over during that meeting. And then also important on that day, before we do the tutorial, we're going to have club elections. And then we have 2 more meetings. Yeah, I'll get there. And then 2 more meetings for the rest of the semester. Basically, with you signing in today and last meeting and the next meeting, you'll kind of dictate what we actually go over those last 2 meetings, kind of what you want to have or what you want to see, what you want to go over. So for election information, the font's off, so if you can't read it, I'm sorry, I'll read it to you. But with elections, we're looking for people to run. We need a vice president, a treasurer, and 2 more officers. So in general, an elected position involves being it's required to promote the club in a positive manner and attend regular scheduled officer meetings. Each officer should build a relationship with other clubs, organizations, and on campus, and with technical companies to help promote the mission of the UF Software Engineering Club. So basically what that just means is you need to be able to have time to come and help promote the club, help do things that are related to the club, like these meetings here, this font's awful, but you get a chance to sort of sit down with companies also and plan technical meetings or workshops or talks and stuff. So it's kind of a fun little thing. This year we only had a couple companies come out and talk, but I think Sergio wants to next year hit on a lot more companies, get more to come out, get them to sponsor a few meetings, food, that kind of stuff. So for vice president, your job is basically to delegate tasks to the chairs. There's going to be a list of after all the elected officials have been elected, there's going to be a meeting, and they're going to come up with all the chairs that they want to have for the next year. The vice president's pretty much making sure that the chairs are doing their job, making sure they know what their job is. And then, of course, there's a software engineering club is sort of a tutorial workshop-based club. So with all of these roles comes it's also implied that you're going to also be able to give tutorials and also be able to communicate to the club members and stuff. All of us give tutorials, that kind of stuff, so you should be able to do that. If it's not as detailed or whatever, you need some guidance, all of that's possible. For the treasurer, it's a little bit different. In terms, we don't really have money right now, but the goal is to have money. The treasurer's job is to manage that money. We're also a sub-chapter of ACM, technically, so we should, the treasurer's job is also to collaborate with the ACM's treasurer, so if we borrow $500, you should keep that sort of written down somewhere and organized so that we know that we owe them $500. Or I think what they're doing next year is giving each club like a budget, and it's your job to sort of manage that budget. And then we're looking for 2 more officers. Just a general officer title. Their job is basically to take tasks that are assigned from the president, attend officer meetings regularly. Like I said, if you're as elected position, you kind of fall underneath that, and basically do anything and everything that you need to do to promote like the general mission of the club and to kind of promote things.
And help run the club.
Yeah, help run the club. So in order to run, you kind of need to have I didn't want to go to the next slide, but oh well. To run, you need to have sort of a slide made for us for the next meeting by March 9th. You can send it to either me or Sergio. Basically, it needs to have a picture of yourself. It doesn't need to be a baby photo, but this is me as a baby. So. And it needs to say what position you're planning on running for. So as an example, I'm running for the vice president position. I've put my accomplishments on. You can put whatever you want in this section. The only thing we're requiring is we know what year you're graduating. If you plan to run for an officer position, you can't be graduating in 2016, so you have to be graduating next April or later. You can be a freshman, sophomore, junior, doesn't matter, just as long as you want to run. Accomplishments, I just listed a few, and then an interesting fact, it's weird that I'm running for vice president considering I'm the president, so. But yeah, so you should just need just a 1-page slide, no more than that to us, and during the next meeting, instead of doing speeches or anything like that, We're just going to go through the slide set, kind of poke fun, and talk about each person, maybe let the person talk about themselves for a second, and then at the end of the meeting, we're going to vote. We're also going to do pizza to get people to come, so bribe everyone for their votes if you know that they're going to be there. So.
And also, like, we'll send out an email with like a detailed list of what exactly you need if you're interested in running. So, and also if you're not on our email list, come talk to us after, and we'll get you on there.
Yeah. As long as you signed up today, you'll be added to the email list.
Yes, that's it. It's if you sign into our link.
Yeah. So really quick, I'll go back to that link just so that you get a chance to sign in. So go to this link to sign in. You'll just be added to our email list. But yeah, running for it's really good to get involved in clubs and organizations on campus. And our goal in Software Engineering Club is to get everyone involved. Sometimes it's a little daunting to go to a big club that's got hundreds and hundreds of members. And I don't know if any of you've been to a Benton Engineering Council meeting. It's like super intimidating, and there's like a bunch of officials, and I mean it's crazy. So we're less crazy, we're more relaxed, and again, it's a good chance to get something on your resume, something good that companies like to see, that you were involved, that you did something. Even if you're not looking to be an officer, you still want to run for a chair position. Those chair positions are going to come available, like I said. We're going to have the first officer meeting right after we get elected. So on March 9th, we're going to be elected in, and then probably that same week, we're going to get all the new officers together, plan out next year's goals and what they want to see happen, and also write down what type of chair positions we're looking for, whether we're looking for chairs to go and talk to companies or chairs to be in charge of some event, or Swamp Hacks is next year, so hopefully we can get somebody from our club to be represented during the Swamp Hacks meeting, so that we're kind of up to date. They're kind of up to date with what we want to see with Swamp Hacks, that kind of stuff. So all of that will be at the next meeting after March 9th. So if you're not looking to run for an officer position, you can still apply to be a chair. With that, John Harrison is going to do the Phaser.js tutorial. You need two things. So you need either Internet Explorer, which is weird, or Edge, which is weird, or Firefox, and you need to download the assets that he's got listed here. And then I'm just going to go and let him start.
Yeah. The reason for those web browsers is these games will work on any web browser, but they have to be hosted on a server if you don't use Internet Explorer, Edge, or Firefox. So Chrome and Safari require you to host it on a server.
Okay, it's going.
Alright, so again, right now we're just looking at an empty Phaser tutorial folder with an index.html file that I just made. So inside the index.html, we're just going to have the normal stuff, which is we're telling people that the doc type is HTML, and then you open your HTML tag and close it. So inside your HTML, you have your head, which is for your meta information, and your body, which is for the documents itself. But really, all we're interested in for the most part is the head. So inside our head, we're gonna include some JavaScript scripts. Initially, we want to include, well, we can't include anything yet because we haven't written anything, but we can give it a title. A Phaser tutorial. Okay, so now we have a very basic index.html file, and we're gonna want to create a new folder within our file structure called source to hold our JavaScript files, src.
You didn't close your body.
Thank you, Alex. So inside source, we're gonna go ahead and make a new file, and we're gonna call that main.js. And this is the main function that we're going to use. So in main.js, we're going to make a new Phaser game. And then the parameters that needs to take in is the width of the window, the height of the window that the game's going to play in, and then the last parameter, it's Phaser, and you can set it to canvas, WebGL, or just auto, which will pick the best one for you. So we're just gonna stick with auto right now.
Are you able to zoom in? Is it
Zoom in. I can probably like increase the.
Double tap like the menu bar.
Wait, I got it. I figured it out.
That works.
Is that better? Yeah. So a thing to know about Phaser is Phaser uses states in order to switch between different like windows of your game, basically. So if you have a menu, you would be in a menu state when you start playing. You'd want to move to like a game state where you're actually playing. It's a lot like Android activities if you've ever done any Android development. So what we want to go ahead and do is add some states to our game. So we're going to initially add something that we will call game state, which is just going to be where we actually play the game. So we give it a title, and then we also declare what JavaScript file it's going to be in, which is game state. And we'll make that file right now, actually. So inside our source folder, we're going to make a new file and title it gamestate.js. And so inside this, we make a variable gamestate equals function. We're taking in the game. So inside a Phaser game state, there's several lifecycle methods that get called. It starts with init, which is initializing stuff, and then it goes to preload, which you want to like preload assets like images and stuff that we're going to be used in the state. Then it'll go to create, which is kind of like the constructor for the state. You create all the stuff on the screen and whatnot, and then after that you have update, which runs continuously. It's an update function. It gets called all the time. It's what you put code that's like changing all the time in. And then finally, there's also a render method if you want to use it to update the view separately from updating the model. But so in order to do this, we just need to make these functions. So we're going to start with a preload function. Actually, no, we're going to start with a create function. I lied. So we have a create function, we have, and we also have a update function. So in order to have these functions be publicly visible, we're going to return them. So in here, so what that does is it gives a like public representation of this object, and it tells you what you can call on it, like its interface basically. So you'll be able to call create and update on this game state object now. And it's mad because
You can ignore those, honestly.
yeah, it's your linter. Okay, so in order to actually start a game state, you need to add game.state.start. And what this wants is the name that you want to start. So we're going to give it game state. So now we have these two JavaScript files, but now it's important that we include these into our HTML in order for it to be able to load them into the web page. So we're going to make a script tag and set the source equal to what ours is. And it's relative, so we just do source and slash main.js. And the next one for our game state. And another important thing, we need to have the phaser file also. So I haven't added it yet, but we'll go to script source equal to and this phaser min.js is the phaser framework that we need to include before we include anything else. And I'm sorry, I actually made a mistake here. Game state needs to be before main, because if you load main before you load game state, it won't have loaded game state yet, and you won't have reference to add that game state. So it's important. The ordering is important here. So what I need to do is basically go on the internet and go to phaser, or just Google it or Yahoo it, and
Use Firefox.
we're gonna download the minified version of the phaser JavaScript. And then I have no idea how this works.
Here, click on Finder. Yeah, downloads.
Ah, there we go. Got it. All right. Wait, where was I before
Go
that?
back click twice.
Okay, I can use the back button. All right, now we're gonna just paste it into source, and voila. Okay, so now we have phaser, game state, and main.js, and we're starting our game state in our main. So in game state, we need to start making our game basically. But before we can really make our game, something we need to do is get all the assets for our game. So we're gonna make a new folder called assets, and it's gonna be at the root level. And we are going to add assets to it, which you can find at the link he gave you. This link right here. This. So you just paste this into the browser. And you have 4 awesome assets here that I wish I could download all at once.
Yeah, it's not Dropbox.
So we're gonna download these real quick. It's
Trying to find out where that's saved
I'm hoping they all just go to downloads.
Yeah.
to. Alright, should have packed this as a folder.
Alright, so once we have our assets, we need to go into our and put them into our new fancy smancy assets folder that we had a second ago. So we get our 4 assets here.
Back.
And then paste them in. Alright, so now that we have our 4 assets that we're going to use, pretty simple game, we're going to start to create the actual game itself. So in our create function, the first thing we're going to do is define which physics system it uses. Phaser has multiple physics systems. One of them's P2, one of them I don't know its name, and the other one is Arcade, which is the most simple. And all we need is Arcade because it's a basic game. So we're just going to use Arcade for now. So we do game.physics dot start system, and we pass it a type of physics, which in this case is phaser dot physics dot arcade, except it's enumerated. So it's like that. So the next thing we can do is set the desired speed we want our game to run at. So we're going to set the time desired FPS. And what this does is it basically tells you how many ticks per second your game's gonna run. So if we set it to 30 FPS, then that means our update function, which is a state thing, will be called 30 times per second. So that's all that's doing. And then for our game, we're gonna create a background. So we'll do bg equals game dot add dot tile sprite, not background. And we're gonna set the first two parameters at x and y position. So 0, 0, because we want it starting at our top left corner. And then we want to set the width of our game, so 800 by 480, which is the height of our game. And then we need to pass it a image here. That's what it wants. But yes.
What is the arcade doing?
The arcade.
Yeah.
So Phaser is a built-in, it's a framework that has multiple physics systems built in. So when you go to when you do this line, it selects the arcade physics system over the other ones. You have to choose one, basically, and arcade is the most simple physics system. Because like with arcade, it's basically all rectangular collisions and it's all like linear stuff. When you move up to like P2 physics, then you can do like irregular shapes and stuff like that. It's going to require more work and whatnot. So here we need our asset, but we don't have it yet. So what we're going to do is go ahead and add a create function. Just switch to force-space tapping.
Honestly, I have no idea how.
Alright, so give me 1 second here. No. Alright. That's the weirdest thing that's ever happened. Alright, so we need something to load in the images. So like I said, we're gonna make a preload function. And that preload function is where we're gonna do game.load.spritesheet for our person. And when you're loading a sprite sheet, this is for like animated characters. So like a sprite sheet is gonna just be one image, but it's gonna have a bunch of like images on it so that you can like animate someone walking and whatnot like that. So this sprite sheet is where we're gonna load in that character asset. So we're just gonna, yes.
On line 12, is that comma there?
I need to add something right here.
Okay.
Yeah. So I need to give it wants a name of an image asset. So we're gonna give it the background, right? But we haven't defined what that is yet. So we actually need to load that in. So you load an image and you give it a name, which we want to call background. Sorry, pro code. And we want to get a background. Sorry, this is not my computer, so I'm not like the most comfortable on it. We want to give it a background, which is its name, and then we want to give it its path, which is just going to be assets. What do we name it? Background2.png. There is no background one.
You have an apostrophe on the line above. The line above.
Yeah. So.
And on line 6 there's another one.
How does this happen? Alright. So with the sprite sheet, we also want to load him in. So we can name that whatever we want. We can name him like dude, for example. And then we're just going to, because that's what the image file is named, it helps keep it organized. And then we want to give it the path to it. Assets/dude.png. And then finally, there's one more asset we want to load for the game, and that's the evil ball. That's just another image. And we're going to point it to assets/evil evil ball.png. Okay, so now we've preloaded all of our assets, but like I was saying earlier, Phaser won't be able to see this function unless you put it in this return. Because this defines the interface for this. So now that we have that, we should have a background. So theoretically, if we run this right now, we will see our sweet background. Let's try doing that. No, don't open Chrome. I lied. So we want to open this with Firefox. Okay, cool. So we have a background loading onto a screen, which is, you know, a decent amount of the way to making a game. So after we make our background, we want to continue setting up the game in our create function. And so the next thing we want to do is make the player. So we'll do player equals game.add.sprite. And this is a phaser call. This adds a sprite to the game, which is something that you can give physics to, and like it'll paint a sprite sheet for, and everything else, it's a sprite. So we give this
Dude.
the initial position and its name, which is dude. Yes. So we're gonna set it to 400, 400, which is just like a arbitrary near the bottom of the screen positioning. And then we're gonna give it game.physics.enable player, comma, phaser.physics.arcade. And this enables that physics on this player, on this sprite. So now we can add certain attributes to it to go around with the physics. So now that it has physics, it'll have a body, and we can give it like, we can set collide world bounds to true. And what that will do is it'll not allow it to exit the screen, basically. Like you'll hit the side, you'll hit the bottom, you'll hit the top. So it keeps them within your screen. So also you can set something like its size. So if we set its body size, we can give it, let's say 20, 32, 5, and 16. And what that's doing is it's setting the actual size of the hitbox for the player. And then finally, we're gonna give it gravity. So player.body.gravity in the Y direction, because we want gravity to go up and down. We're gonna give it like 1,000 gravity. So now we should have a dude on our screen, and you should see him fall like an inch or so with the gravity.
Command R is refresh.
Yep. All right, so what we have here is an entire sprite sheet of a dude, and what went wrong there is I defined this as a sprite sheet, but then I didn't give it the frames, the number of frames it had, so it's assuming that there's just one frame, or the size of the frame. So what I need to do is set 32, 48, and that's the width and height of the frames. So now it'll cut up that long sprite sheet into individual frames, theoretically. So now we have a dude on a screen, and you can see he's colliding with the bottom world bound there, and you can see him fall for a second when we reload it, and that's the gravity acting on him. So the next thing we want to do probably is give this player some movement, right? So what we're gonna do is go ahead and create a function to give him movement. Doesn't really matter where you put it.
The tabs are messing up because I have like an auto. Whenever you save, it'll like auto format it to the appropriate tab. So, like just like write your function and then
Okay.
do command S
Alright.
and it'll auto format everything.
All right, cool. Good to know. Good to know. So we have we're just gonna name it like move player. That's not how you write JavaScript. And in this function, we want to handle all of the things to move the player. So we're gonna do. Let's see. I might have gotten ahead of myself here just a little bit. So before we go this far, before we can give the player movement, in our create function, we need to define something to take input from the user. And Phaser has this already ready for us. So we're just gonna say game.input.keyboard.create cursor keys. And what that does is it creates an input handler for us, basically, that we can call and stores in cursor. So I have these variables here, cursors, player, and background, and right now they're just in this create function, but I actually want them accessible throughout my game. So what I'm going to do is just go ahead and declare them out here. Now, in our move function, we can start defining some of the logic. So we'll create if statements, and what we're gonna do is we're gonna check if cursors.left, which is the left arrow key, and we check it's a boolean, is down. So if the left arrow key is down, what do you want to do? And what we're gonna do is set the velocity equal to -200, which is going left on the screen. Positive 200 would be going right, or positive anything would be going right, negative anything would be going left. And velocity is just part of the arcade system. It allows you to, it does the math for you, and it'll change the position without you having to explicitly do that, just by setting the velocity of something. So now we also want him to be able to move right. So if cursors dot right dot is down, player dot body dot, then we'll set the velocity to 200. But we don't want to do this at the same time. So we're actually gonna make that an else if, so you can't do both at once. Then we want to also allow our player to jump. So we're gonna go ahead and make an if cursors dot up dot is down. Then we're gonna say player dot body dot velocity dot y. Okay, I apologize. This should be x velocities because you're moving left and right. It wouldn't make sense to just give velocity a magnitude like that. So we're gonna set the y velocity equal to 400. So right now, our player still isn't gonna move if we load this game And that's because we don't have anything in the update function to tell to do it. Now if we call move player from the update function and we load it here, then you can see that we are able to move left and right. Jump doesn't work, so we'll have to figure out what's going on with that. But we have left and right movement, and it's going to collide with the world bounds. But what's kind of annoying is like when I press a button, so like I'm going to press right once, and his velocity is set, right? So he's going to continue moving right, which isn't really what you want. So in our function up here, let's go ahead and at the very beginning, just set the player velocity to 0 for the x-axis. Now, when we load the game,
X, you just did velocity.
thank you. Yeah, so it's not gonna know what you mean if you just say velocity, because there's no such thing. Now, when I hit right, I move right and I stop, which is kind of more desired behavior. So you're actually able to like move left and right, and you're not moving when you're not hitting the arrow keys. So now the question is, why did jump not work? And that'd be because Y velocity 400 is actually down, and negative 400 is actually up. So now when we load it and we press up, yay, he jumps. That's if you hold it down. So like if you hit it once, he'll jump that high. But right now, there's nothing to prevent it from double jumping. Like you're just like a really good jumper right now. So yeah, we have player movement right now. Pretty cool. So let's see, what do we want to do next? So next, we probably want some sort of enemy for our player to face. And so we're gonna go ahead and create some enemies, and they're gonna be evil balls. So I'm about to do something here, and I'll explain in just a second. I'm adding a group, and so this is a phaser thing. You can add groups. So by adding a group, I can group a bunch of sprites into one group, and that way I can treat that group as a whole thing. So it's convenient if I want to have a bunch of evil balls on the screen, and I group them all into one group. That way, when I'm checking for collision and stuff like that, I can just check entity against evil balls group. So any evil ball in the evil ball group will do the same collision detection, call the same function. So that's the point of creating this group, basically. We also want to enable their body because this allows them to collide, basically. And then we need to set their physics type for the group, just like anything else. Okay, so now we created that group.
Did you misspell body?
Probably.
Boy.
Thank you. So does anyone have any questions right now? Yes.
Can you show us the main file real quick?
Yes, I can. So all we're doing here is adding our main game state, and then we're starting it up at the bottom. And we're also declaring our game at the top, which we're passing into our game states.
Can you also show the index HTML in?
Mm-hmm. Are you good with?
Single picture.
Oh no, it's okay. We're fine. Oh, I was gonna try to like drag it out, but I'll just leave it there. Yeah, so the index HTML doesn't have too much going on. What we're doing is we're just importing the JavaScript files that we made. And the order is actually important. Phaser needs to be first because all these files depend on phaser functions. And then main pretty much needs to be last because main is what we're going to use to add all of our game states and actually start them up. So all of those things already need to be like loaded in before we call the main and start like actually loading everything up. Is everyone good with the index? Okay. So back in our game state, we've started to create this evil balls group, but we haven't actually made any objects yet. So what we want to do is in our create function here, just make a for loop so we can make a few of them. We'll say I less than 15 plus I. And what we're going to do is we're going to call evil balls, which is our group that we already created, and we're going to call create. So we're going to make something within this group. And we're going to use phaser functionality here to randomize their position on the map. So what we do is game.world.randomX. And then we're also going to randomize their Y, but we're not going to use the same function because we don't want them spawning on top of our player before the game starts, because eventually the goal is if the player collides with these, he loses the game. So we're going to use JavaScript's math.random, and it works just like any other JavaScript class, really. Wait. So yeah, we're going to put them anywhere between 0 and 380, basically. That's how that would work. And then we want to give them an image, so we'll give them that. So now we've just created these evil ball objects. So if we go to the browser, we can see when we refresh, it's created a bunch of these evil ball objects, right? And like nothing happens right now. I can just like go near them, through them, anything. They're not moving. Nada. So what we want to do is we want to make these evil objects move, but we can't be the ones controlling them, right? We have to do it with code. So we're going to make a new file, and we're going to name it evil ball controller. And the whole point of this JavaScript file is just to move these evil balls around so they have like their own little AI mind of their own. So var evil ball controller, this new function. So inside this, we're going to give it like standard phaser functions. So we're going to give it an update because we want it to be moving actively. And then we're also going to give it a method called change direction. And this will use randomness also.
We forgot to name the file .js.
That would be why there's no syntax highlighting. So
On the left, I believe you can right click and rename it.
yeah, so we're gonna refactor this really quick. And now you see all of our sweet syntax highlighting. And then finally, as with every other thing, we want to give it the return of its interface. Okay, so we have this class, and we want to move around a sprite within it. We want to move an evil ball object, just one of them within this object we have here. So what we're going to do is we're going to pass that in. So we're going to call it sprite here. And inside our update function, basically what we're going to do is we're going to make sure that well, it's not best to explain that first. So first, let's just set up the change direction function. So we're going to use randomness to determine which direction it goes and how fast it goes. So we're going to say x velocity equals math random times, let's say 300. So now this x velocity variable can be anything between 0 and 300. But we don't want it going quite that fast. And we want it to be able to go left and right. And this is only positive numbers. So now we're going to say if x velocity is greater than 150, which is half of that, then let's subtract x. Let's subtract 151. And what that does basically is when you roll a random number between 0 and 300, if it's 0 to 150, it'll be anywhere between 0 and 150. So it'll go x, so it'll go right 0 to 150. If it's greater than 150, then it'll subtract 151. So now it gives us the ability to go from -1 to -150. So it can go either direction, basically. That's all this is doing. And then we want to do the same thing for our y velocity. Okay, so now we've got these two variables, and all we need to do is actually apply them to the sprite. So this is the same sprite that we passed in. Velocity.x equals x velocity. So now we're setting the sprite's x and y velocity. So this is pretty good because it's going to be able to change direction whenever this method is called. But right now we don't have any way to bind this controller to the actual sprites themselves. So we need to add that functionality into our create state when we actually create them. So here we have this object, or this loop creating a bunch of these evil balls. And now when we're creating them, what we want to do is we want to do var controller equals new evil ball controller, and as an argument it takes in that ball you just created. So now we're creating a controller with each ball and giving it to it. Yes? So the first parameter here is the x coordinate that you want to create it on, and the second parameter is the y coordinate you want to create. So it's an x and a y for where you want to create this object. So with game.world.randomx, it'll give you anywhere within the x-axis of the game window. But with y, we don't want it to go all the way down to where the player spawns because we don't want the player to instantly lose. So I cut it off at 380, even though the window's height is like 480, so we get like a 100 pixel barrier. So now we've bound this ball controller to the actual ball, but we want a way to keep track of all of these controllers so that we can reference them later in the code. So what we're going to do is we're going to create an array of them. we're just gonna call it ball controllers and declare that array. And down here, we will say ball controllers dot push is the JavaScript syntax. And we're gonna push that controller that we just made. So now, this won't actually do anything yet, and the reason is because we don't have anything in the update function. So now, if we make a for loop here for ball in, or let's rename that, for controller in ball controllers. It's just a for each loop, kind of. Ball controllers. What did we name that function? Change direction. So now we're just referencing, so now in the update function we're saying each ball controller change the ball's direction on every update. So now if we open up our Firefox browser.
Should that be like controller and then ball? Or?
That's what it should be, I'm sorry.
Yeah, yeah.
Yes, so I had it originally named as ball, but yeah, so.
Well, couldn't you just do like controller dot change direction if you're doing the for each loop? Well,
I thought so, but let's test it out. I'm not sure. I'm not the JavaScript god. I'm not saying that's the issue. Let's
Or you know you can't. This is, the ball is the index of the variable ball.
So we have an error, and the way we debug that is by opening our inspect element. This just means one you didn't correct me.
Did you?
Oh yeah. Yep. So Sergio already knows what's wrong. We made a new JavaScript class, and we're trying to reference it and everything, but in our index, we never actually told the web browser about this file, so it has no idea that it even exists. So now we add this really quickly. So once we've given it reference, it should theoretically work here.
I think it's because you called new function when you made the evil ball controller.
Oh. Yeah.
Go to the evil ball controller like .js, and you have new function.
I'm sorry. I code a lot in Java too. Okay. So yeah, fix that. Sergio's on top of things here. And now we have all these balls wiggling around, but they all just left, which is really sad. So let's go ahead and code them so that they can't leave our playing area. So in our ball controller, we're gonna put this functionality in our update function. We could put it in change direction, but we're gonna change where change direction is called, so it's called less often, so they're not wiggling so much, and they'll just change every few seconds, so it's more like set. And so in update, we'll call update constantly. So what we're gonna do is constantly just check if the ball is out of the bounds, and this is not very exciting code. So sprite, if sprite.x is greater than 800, which is the width of our screen, then sprite.x equals 0. So basically, if you have a screen and you're going off this side, then come back on the other side. So it's like a kind of like a endless loop now. The screen, like if you're going off one side, you'll start to appear on the other side. So in the same fashion, if sprite.x is less than 0, then we'll set it to 800. And then we'll do the same thing for the y's. The only difference is the y is not as tall. So if sprite.y is greater than 480, then sprite.y equals 0. And if sprite.y is less than 0, then set it to 480. So this, theoretically, will keep our balls from leaving us, which was the issue we had a second ago. So let's test it out. It didn't, and that's because we never called the update function. So if we go into our game state here, we're calling change direction. If we also call, let's try calling it just this way, which was suggested earlier. Because that does look a lot nicer. Oh boy.
Yeah, it's set control.update's not a function, so I guess you can't do that.
Yeah, and that's originally how I thought the for each loop would work, but now when we load this, you can see that when they go off the screen, they're just reappearing. But I'm noticing this interesting trend where they're all going down, so I'm starting to think that the code is not correct on the Y side of things.
Should it be minus or equals 300?
Yes, you are 100% correct. I did that head math wrong. It needs to be one more than the max to achieve the effect we wanted. So now they should do what we want. So let's refresh them. And now they can go in every direction, which means they just like to wiggle in place pretty much. Which is kind of crazy and really not that nice other than looking kind of cute. So what we're going to do is we're going to make a variable with a timer initially set to 0. And this timer is going to control when our little buddies actually move. So here we're going to set our, well, we don't want to redefine it. Timer equal to game.time.now, I believe. Give me 1 second. Yeah. So basically, when we want to say if timer is greater than game.time.now, then we should set timer do something, and then set timer equal to game.time.now plus 1000, and game.time.now is in millis, so 1000 is 1 second, so maybe we do 4 seconds. They change direction every 4 seconds is our goal here. So if timer is greater than game.time.now, then we want to call the change direction. And if it's not, we don't want to do it. So this theoretically, we'll call it every 4 seconds they'll change direction. So hopefully the goal is that they won't wiggle so much. Or they just won't work at all. Less than. Math is hard. So now, every 4 seconds you can see they change directions, which is kind of cool and the desired effect. Does anyone have any questions up to this point? Yeah.
In the, if you scroll up, like go up, yeah, you said that in the create y parameter is for not getting those evil balls down on the y, 380 math.random.
Yeah.
That is for not them like.
It's the, okay, so let me open this up. It's so when you like enter the world, none of them should be right where the player is initially. Like there should be like this 100 pixel padding at the bottom where they can't get to, because this is 480 pixels tall, and basically what I'm saying is they can spawn anywhere between 0 and 380, so it leaves like that safe space initially for the player. And it doesn't really matter right now, but in just a second we're gonna add collision, sorry, so that you can die and lose the game. So yeah, that's probably what we want to do next, is add collision with the balls so that we can actually lose our game. So let's see. For this, we will call on the physics system, and we will call its collide function. And what this does is it takes two objects, in our case, player for the sprite, and we're going to give it the group evil balls, which is one of the reasons we grouped them, so we could do this. So any of the evil balls basically collides with players. And then what we're going to do is give it a callback function. And this is basically just the function that will get called if this event happens. And so we'll call it like hit ball. We haven't actually defined this function yet. So now we'll go up here and just make a new function. Var hit ball. And inside our function, we want to handle what happens when the player collides with a ball. So just to test it out, let's go ahead and just console log. Boom, I hit a ball. And let's see if we get that to print out when we run this. So if you can see me hitting these balls here, I think. Wait, it printed once, but wait, let's see that again. Okay, it's printing every time I hit a ball. It's just the browser's smart. You can see the little number right here. It's just concatenating repeat outputs into one thing. So yeah, we're getting a new one every time we hit a ball. So we have collision working, which is pretty cool. And go ahead and add a way to end the game. So we're gonna make one new class in our source folder. And this is gonna be gameover.js. And so this is where we're gonna put like the you lost the game basically. So var game over state equals function. We're going to give it a preload function because we want to load in the play again button. So game.load.image. We want to call it play button, and we're going to get it from assets / play button.png. So that will load it in, and we're also going to have a create. And then we're going to return these methods as the interface. And then inside so we've just loaded in that image. So inside of this, we want to create our button. So what we're gonna go ahead and do is say var play button equals this dot game dot add dot button. So it's Phaser's way of adding a button, and it wants you to give you a position. So we're gonna give it 400 and 240, which is just the middle of the screen. We're gonna give it its image that it wants, which is not that. So what we called the image file that we cached in, and then it wants also a callback method for when you click it. So like the action listener. So we can just name it like button clicked or something. And then we can define that function up above. And so do something. Actually, let's have it be testable. So we're gonna have it just print out like I clicked a button or whatnot. So all this will do is put a button on our screen, but we can't actually get to the state yet. So what we want to do is go into our main.js, add the state so it exists. We can call it whatever we want. We'll call it game over state. And then we're gonna give it game over state, which is what I named the JavaScript function. So now, in order to get to this, whenever we collide with something in our game, we want to be sent to the game over screen. So before we were just printing out that we hit a ball, but now we actually want to do game.state .start, and we're going to give it the name of a state. So we're going to give it game state, and then we're going to pass it two booleans, and these are whether you want to clear the cache and whether you want to clear like the level, I believe. So basically we're saying if we hit a ball, then start the game state. And now let's take not game state, we're in game state. Game over state. And now let's take very similar code over here. We can just copy paste this into game over, and we say in our function up here, if we click this button, play again, then go back to just the game state. So now when we test this,
did you add to the index.html?
Sergio is always correct. So in order to save me embarrassment here, what we need to do is add this new game state to our index.html. So script source equals source. Alright, now we will try loading this. And when we hit a ball, we get taken to this game over state. And if we hit play again, we get a sweet error. It's unfortunate. So one thing we can do with the play button, you saw it wasn't quite centered, even though we put it at the center of the screen. But if we do play button dot anchor dot set to, I believe this could be wrong though, 0.5 0.5, that'll set the pixel anchor to the very middle of it so that it should be centered when we put it at the center coordinates. Okay, so now we have a centered button at least. So what the error we got was that sprite.body is null. And basically what's happening is there are objects in our game JS
Is it an issue if you're reinitializing all the balls every time?
reinitializing which, sorry.
The balls?
That would be an issue.
Because you're using new balls, right?
Yes. So normally what happens, or when I originally did this, what I did is whenever you died, I would go through the ball controller array and remove those ball controllers and then reassign them the next time. But I think you have a point. Because I'm not 100% sure. Why would the player's body be null?
Because you're the game over state, you're doing a true where you're wiping everything.
It should be reinitialized when I call the create function. Yeah. Interesting. This is an interesting error.
Is it not with like the start button when you click it? Is there an issue with that?
Yeah, it's basically it's trying to, I think it's trying to update for some reason before it should be on the player's body velocity. Let's see, move player.
What line was it?
That's a good question, actually.
28 in evil ball.
Oh, it's okay. So it is an evil ball controller. I'm sorry.
Okay.
Yeah. So, and there may be a better workaround than this, but basically, when we collide, our evil ball controllers are still in existence because they aren't controlled by phaser. So we basically want to just go through and remove them because they won't get removed automatically by phaser when you switch states and clear phaser's cache. So right before you switch states, you simply want to go through your array of ball controllers
You just set the array to an empty array.
and delete them. You may just be able to set it equal to an empty array also. And now, when you hit play again, it works. So that was the issue. What was happening is there was old ball controllers that hadn't been deleted, but phaser had deleted all of the balls that they were actually linked to. So now they're just full of like these like hanging pointers, and like they were just pointing to nothing actually and trying to call functions on it, and that's why it was crashing. So yeah, we have a basic working game here with, and the reason they don't move immediately is we can fix that in our create function at the bottom after we declare the controllers. If we put this logic, which should be in a function, because you've seen me paste it a few times now. If we move it, so it calls that every time it calls create, then, oops. But as you can see, we immediately get back to playing. They get back to moving, I should say. We immediately start again. Yeah. All right. So there. What's up?
We're gonna go.
Yeah. That's our basic game tutorial for today. I hope you guys enjoyed it. We will be putting some code online that has like a scoring system built in, so the longer you can stay alive, the higher your score will be. And so if you're interested in checking that out, we'll upload it to our GitHub, and you'll be able to see that. But I hope you enjoyed this. If you guys have any last questions before I leave, you can talk to me after the meeting. I'll be happy to talk to you.
Did you comment the code that you published a bit more too?
Comment it? Yeah.
Yeah, and then we're gonna post a video of this, the screen record, just like all the other meetings. All that will be available online as well.
Yep. So thanks for coming out.
Thanks, guys.